Preparing for a mobile application engineering at HCA Healthcare interview? You've reached Candy Mentor, and this video is for you. We'll walk through 25 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you architect a mobile healthcare application for both Android and iOS? I would separate presentation, domain, and data layers, then keep platform-specific UI native while sharing stable business rules where practical. Android could use Kotlin, Jetpack, and Compose. iOS could use Swift, SwiftUI, and async APIs. A repository layer would isolate networking, caching, and authentication. For healthcare, I would add audit logging, encrypted storage, consent handling, accessibility, and offline safe workflows. I prefer shared logic only when it reduces duplication without weakening platform conventions or user experience. While answering, cover platform-specific layers, shared business logic, native user interfaces, API boundaries, modularity, security, offline behavior, testing strategy, accessibility, and how architecture supports long-term maintainability. Question 2. How would you protect patient information in an HCA Healthcare mobile application? I would minimize sensitive data on the device and encrypt any required cache using platform security APIs such as Android Keystore or iOS Keychain. All network traffic would use TLS, with careful certificate validation and short-lived tokens protected by secure storage. Authorization must be enforced server-side, not trusted to the client. I would prevent sensitive logs and screenshots, support remote session revocation, and perform threat modeling against lost devices, compromised accounts, reverse engineering, and insecure third-party dependencies. Make sure to cover encryption in transit and at rest, secure key storage, authentication, authorization, token handling, logging restrictions, certificate validation, least privilege, privacy regulations, threat modeling, and secure data deletion. Question 3. How would you design authentication and session management for a healthcare mobile app? I would use OpenID Connect with an authorization code flow and PKCE, avoiding embedded credentials and client secrets. Access tokens would be short-lived, while refresh tokens would be rotated and stored only in Keychain or Keystore. Biometrics could unlock a locally protected session but should not replace server authorization. I would support multi-factor authentication, inactivity timeouts, remote revocation, device management, and clear recovery flows. Every API request would enforce scopes and patient access permissions independently. In your answer, discuss OAuth 2.0 or OpenID Connect, multi-factor authentication, biometric convenience, refresh token rotation, secure storage, session expiry, device trust, revocation, authorization scopes, and recovery for patients and caregivers. Question 4. How would you implement offline support for appointments, messages, or health information? I would first classify what is safe to cache. Appointment details might be available offline, while clinical results could require an explicit freshness warning or remain online only. Encrypted local storage would use a repository and sync queue with idempotent operations, exponential backoff, and connectivity-aware retries. Server timestamps or version numbers would detect conflicts. The interface would clearly show offline status and last synchronization time, because stale healthcare information must never appear current. Be sure to mention data classification, local encryption, cache freshness, synchronization, conflict resolution, retry policies, connectivity detection, user feedback, stale data warnings, and the risks of displaying outdated clinical information. Question 5. What mobile architecture pattern would you choose, and why? I would use a pragmatic clean architecture with MVVM and unidirectional state flow. Views render immutable state and send user intents to view models, while use cases coordinate repositories and domain rules. This keeps networking, persistence, and healthcare-specific validation testable without UI dependencies. I would avoid creating layers merely for ceremony. Simple screens can remain simple. The key is consistent boundaries, predictable state transitions, and dependency injection that supports unit and integration testing. While answering, compare MVVM, clean architecture, and unidirectional data flow. Explain dependency boundaries, testability, state management, lifecycle handling, team scalability, and avoiding excessive abstraction. Question 6. How would you build a robust networking layer for Android and iOS? I would place a typed client behind repository interfaces and map transport models into domain models. Requests would define connect, read, and total timeouts, with retries limited to transient failures and safe idempotent operations. Cancellation must follow screen and task lifecycles, especially during searches. I would centralize authentication, pagination, error mapping, and correlation identifiers, while avoiding sensitive telemetry. API versioning and contract tests would protect mobile releases from backend evolution. In your answer, cover typed API models, REST or GraphQL decisions, timeout policies, retries, ID impotency, pagination, error mapping, cancellation, observability, TLS, versioning, and graceful handling of partial failures. Question 7. How would you handle a breaking backend API change when older app versions remain installed? I would assume multiple app versions coexist and require the backend to remain backward compatible during a defined deprecation window. New fields should be additive, and behavior changes should use versioned endpoints or capability negotiation. Feature flags allow gradual activation without forcing an app update. I would monitor request failures by app version, communicate upgrade requirements clearly, and provide migration logic for local data. A hard cutoff would be reserved for security or regulatory necessity. Make sure to discuss backward-compatible contracts, API versioning, feature flags, capability negotiation, deprecation windows, staged rollout, minimum supported versions, migration logic, and monitoring failed client requests. Question 8. How would you design appointment booking to prevent duplicate or conflicting reservations? The server must be authoritative because two users can select the same slot simultaneously. The client would request availability, but booking would revalidate it inside a transaction. I would send an ID impotency key so retries cannot create duplicate appointments, disable accidental double taps, and return a clear conflict if the slot disappeared. Appointment times should use canonical server time with explicit time zones. The app would distinguish pending, confirmed, failed, and cancelled states. Discuss server authority, ID impotency keys, availability revalidation, optimistic versus pessimistic approaches, transaction boundaries, retries, time zones, double submissions, user confirmation, and handling appointment cancellation or rescheduling. Question 9. How would you implement secure messaging between patients and care teams? I would model conversations with server-enforced participants, role-based permissions, message identifiers, timestamps, and immutable audit events. Transport and stored content would be encrypted, and attachments would use short-lived authorized URLs with malware scanning. Push notifications should say only that a message is available, never reveal clinical text. The client would show sending, delivered, and failed states, retry safely, and prevent unauthorized local previews. Retention and export behavior must follow organizational policy. Be sure to cover identity verification, authorization, conversation ownership, encryption, attachment handling, push notification privacy, delivery states, audit trails, retention, moderation, and preventing message leakage through previews. Question 10. How would you handle push notifications for appointments, results, and care reminders? I would register platform tokens securely and send them to a server that owns notification policy, audience rules, timing, and deduplication. Notifications would contain generic text and a protected deep link, not patient details. The app would handle foreground, background, and expired link cases consistently. Users should control categories such as reminders or messages, while critical communications follow approved policy. Token rotation, permission changes, delivery metrics, and opt-out behavior require monitoring. While answering, mention platform tokens, notification consent, deep links, privacy-safe content, server-controlled delivery, deduplication, expiration, localization, foreground handling, analytics, and behavior when users revoke permissions. Question 11. How would you make an HCA Healthcare app accessible to users with disabilities? I would treat accessibility as a design and acceptance criterion, not a final audit. Every control needs a meaningful accessibility label, logical focus order, adequate contrast, scalable text, and a touch target suitable for motor limitations. Forms should expose specific errors to screen readers, while videos need captions and motion should respect system preferences. I would test with talkback and voiceover, automated checks, keyboard navigation, and people who use assistive technologies. In your answer, cover screen readers, semantic labels, focus order, dynamic text, contrast, touch targets, captions, reduced motion, error messaging, localization, keyboard access, and testing with assistive technologies. Question 12. How would you diagnose and improve poor mobile application performance? I would measure before optimizing, using Android Studio Profiler, instruments, traces, and production telemetry. I would separate startup, rendering, network, database, and memory problems rather than guessing. Typical fixes include lazy initialization, pagination, image resizing and caching, indexed queries, background work, and reducing unnecessary recomposition or view updates. I would define budgets for startup and interaction latency, compare real device percentiles, and verify that a speed improvement does not increase battery drain. Make sure to discuss profiling, startup time, frame rendering, memory, network latency, battery use, database queries, image loading, release monitoring, performance budgets, and measuring improvements with real user data. Question 13. How would you prevent memory leaks and crashes in Android and iOS applications? On Android, I would scope coroutines and observers to lifecycle owners and avoid retaining activities in long-lived objects. On iOS, I would inspect closure capture lists, delegate ownership, and task cancellation. Large images and collections need bounded lifetimes and incremental loading. Leaked canary, instruments, symbolicated crash reports, and automated tests help find regressions. I would prioritize crashes by frequency and impact, reproduce them with device and OS context, then ship guarded fixes. Discuss lifecycle-aware components, weak references, observer cleanup, coroutine or task cancellation, retained closures, large resources, leak detection, crash reporting, reproducibility, and prioritizing issues by affected users. Question 14. How would you test a cross-platform healthcare mobile feature before release? I would start with unit tests for validation and domain rules, then repository integration tests against controlled services and contract tests for APIs. UI tests would cover login, booking, messaging, accessibility semantics, rotation, interruptions, and offline recovery. Security testing would include token handling and storage inspection with non-production data. A device matrix would represent supported OS versions and screen sizes. Finally, exploratory testing with realistic personas would target high-risk patient journeys before staged rollout. Be sure to mention unit, integration, UI, accessibility, contract, security, performance, localization, offline, device matrix, test data privacy, automation, and exploratory testing for high-risk workflows. Question 15. How would you release a critical mobile application update safely? I would build signed artifacts through reproducible C pipelines with unit, UI, security, and release checks. Risky functionality should be protected by remotely managed feature flags and a server-side kill switch. I would release internally, then to a small production percentage, watching crashes, latency, funnel completion, and support signals before expanding. Because App Store rollback is slow, backward-compatible APIs and server controls are essential. Security or patient-impacting defects require an explicit incident communication plan. In your answer, cover C, CD, signing, automated gates, phased rollout, feature flags, monitoring, rollback limitations, kill switches, store review, crash thresholds, and communication for security or healthcare impacting changes. Question 16. How would you use Kotlin and Swift effectively in a shared mobile engineering team? I would write idiomatic Kotlin and Swift rather than translating one language mechanically. Kotlin null safety, coroutines, sealed results, and Jetpack conventions should feel natural on Android. Swift optionals, actors, async await, value types, and Swift UI patterns should guide iOS. Teams can share API schemas, domain terminology, testing expectations, and design behavior without forcing identical code. Clear platform ownership, cross-platform reviews, and documented contracts prevent divergence while preserving native strengths. While answering, compare idiomatic Kotlin and Swift, null safety, structured concurrency, value semantics, platform APIs, code review standards, shared contracts, interoperability, and avoiding forced language symmetry. Question 17. How would you manage state in a complex mobile screen such as a patient dashboard? I would represent the dashboard with an explicit immutable state containing loading, content, partial failure, and retry information. User actions become events processed by a view model or reducer, while repositories coordinate concurrent requests and expose cached data safely. Lifecycle restoration should preserve meaningful filters without replaying dangerous actions. Each section can render independently, but timestamps and source status must be visible. This approach prevents hidden mutations and makes state transitions straightforward to test. Discuss immutable state, loading and error states, one-way data flow, lifecycle restoration, concurrent requests, caching, event handling, partial rendering, retry behavior, and preventing stale or contradictory information. Question 18. How would you integrate electronic health record or healthcare interoperability APIs? I would treat FHIR resources as external contracts, not as direct UI models. An integration layer would authenticate with scoped OAuth, validate responses, map terminology, preserve provenance, and convert resources into stable domain objects. Consent and patient identity matching must be explicit, and unavailable systems should produce honest partial states. I would handle pagination, rate limits, retries, and schema extensions defensively. Clinical data needs timestamps, source context, and clear distinctions between missing and unknown. Make sure to cover FHIR resources, OAuth scopes, consent, data normalization, pagination, terminology mapping, provenance, rate limits, unavailable systems, validation, and separating clinical meaning from presentation models. Question 19. How would you design digital check-in or virtual care workflows for unreliable connectivity? I would model check-in as a durable state machine, initiated, identity verified, forms pending, submitted, payment pending, and completed or requiring assistance. Each transition would be server confirmed and resumable after interruption. Pre-flight checks would validate camera, microphone, permissions, connectivity, and appointment eligibility. Video should adapt quality and offer a fallback contact path. Sensitive forms would be encrypted locally only when necessary, with clear progress, timeout, and completion confirmation. In your answer, discuss workflow state machines, pre-flight checks, permissions, resumability, queuing, timeouts, fallback channels, privacy, video quality adaptation, accessibility, and clear communication of successful completion. Question 20. How would you investigate a production issue reported by patients on only one mobile platform? I would segment the report by platform, OS, app version, device model, locale, network, and account state. Crash symbols, breadcrumbs, request correlation IDs, and sanitized logs would reveal whether the fault is UI, API, storage, or platform specific. I would reproduce on an affected device or simulator, compare recent changes, and use a feature flag to limit impact. After fixing, I would test the original matrix, deploy gradually, and confirm recovery through targeted telemetry. Be sure to mention reproducibility, device and OS segmentation, release correlation, crash and log evidence, feature flags, binary differences, privacy-safe diagnostics, rollback options, and validating the fix with affected users. Question 21. How would you ensure privacy-safe analytics in a healthcare mobile application? I would define an event taxonomy around product behavior, never around unnecessary clinical content. Events should exclude names, diagnoses, message text, precise identifiers, and tokens. Use pseudonymous identifiers only when justified. Consent, retention, role-based analytics access, and vendor agreements must be documented. I would review SDK behavior, disable automatic capture where needed, and sample safely. The goal is learning whether a workflow works, not collecting more patient information than that question requires. Discuss data minimization, event taxonomy, consent, de-identification, prohibited fields, access controls, retention, vendor review, sampling, correlation identifiers, and balancing product insight with patient confidentiality. Question 22. How would you handle secure local storage and database migrations across app versions? I would store only necessary data, encrypt sensitive records, and keep encryption keys in keychain or keystore rather than application preferences. Database schemas would use explicit versions and tested, atomic migrations, with backup exclusion for protected caches. Migration failure should preserve recoverable data or trigger a controlled re-download, never silently corrupt records. Logout would remove tokens and appropriate cached information. I would test upgrades from several supported versions, interrupted migrations, low storage, and corrupted files. In your answer, cover encrypted databases, keychain or keystore, schema versioning, backward compatibility, atomic migrations, corruption recovery, backup exclusion, logout deletion, and testing upgrades from realistic legacy versions. Question 23. How would you collaborate with clinicians, product managers, security teams, and designers on a mobile feature? I would begin by observing the real clinical or patient workflow and translating it into measurable acceptance criteria. Clinicians validate safety and terminology, designers validate accessibility and usability, security reviews threats and data handling, and product clarifies value and scope. I would use prototypes to expose assumptions early, document decisions, and raise risks with alternatives rather than silently accepting them. For conflicts, patient safety, privacy, and operational reliability outrank cosmetic preferences or short-term delivery pressure. While answering, emphasize requirements discovery, clinical workflow validation, privacy and safety review, shared acceptance criteria, prototypes, trade-off communication, user research, documentation, and resolving conflicting stakeholder priorities. Question 24. How would you prioritize technical debt in a healthcare mobile codebase? I would rank debt by patient or operational risk, security exposure, crash impact, change frequency, and engineering cost. A vulnerable dependency or unreliable medication workflow deserves priority over an untidy but stable abstraction. I prefer incremental refactoring alongside feature work, supported by tests and measurable goals such as reduced crashes or faster releases. I would make the trade-off visible to product partners, reserve capacity deliberately, and avoid a broad rewrite unless evidence shows incremental work cannot manage the risk. Make sure to discuss risk scoring, patient impact, security exposure, crash frequency, delivery friction, dependency age, measurable outcomes, incremental refactoring, stakeholder alignment, and avoiding rewrites without evidence. Question 25. Tell me about a mobile engineering decision you would make differently in hindsight. In one project, I initially introduced a shared abstraction to keep Android and iOS behavior identical. It reduced duplication but slowed both teams because platform-specific requirements became awkward exceptions. After measuring cycle time and reviewing defects, I moved shared rules into a small domain layer and let each platform own presentation. The change improved delivery and reduced conditional code. My lesson was to share contracts and business logic selectively, while validating architecture against team productivity and user outcomes. In your answer, describe the original context, decision, measurable consequence, feedback received, corrective action, ownership, and lesson learned about validation, communication, architecture, security, or user impact. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.